Hi, welcome to this session. I'm going to talk about how the Shellshock attack works. First, I will start with the very basic idea of what an environment variable is and how environment variables are being targeted in this Shellshock attack. So let's get straight into defining an environment variable just to get ourselves familiar with it. Let's define an environment variable, say XYZ. Just take a simple example, my environment variable, right, is equal to XYZ. Okay. If you wanted to have something more realistic, maybe my lang is EN. Okay. And if you wanted to look at the value, we can do like this. Okay, it's EN. If we now export this variable value, export something like this. If we create a child process, let's create a child process. Maybe I will change the prompt name so that it looks like we are working in parent. Okay, this is the parent process, right? And now we will create a child process. Let me change the name of the child process. When I say name, just the prompt of the Unix command line. Now let's look at whether the environment variable that was created by our parent is visible to the child. Yeah, it does. Okay, that means we can create an environment variable in our parent process, and when we do export, the value of the mylang variable was transferred to the child. That's how we are able to see the value of the environment variable. Okay, let's get out of the child. Now we are back into the parent process. Let's define a function because the Shellshock attack requires us to define a function. There are a couple of ways to define a function. Let me start with the very basic way. First fun, right? First way is basically simple. You do like I am the first function, right? Something like this. So you created a function, very basic function, and you could ask the bash to show your function definition, right? It will show the function definition. Now let's run it. How do we do that? Yeah, so it is echoing the output. I am the first function, right? First fun. Okay, now if you want to, for some reason, delete this function, you just do unset function first function. Okay. Now, if we ask for a declare, hopefully it doesn't show us anything because we deleted the function definition. So that's basically how we define a function. Now, let's create a function, create the same function again, because I wanted to export this function now. Okay. What I'm going to do is just going to export this function. Export means, as you know, it will be available to the child process. Okay. Now I will be spawning a child process. Okay. And I need a better prompt name. You can choose whatever name you wanted here. There's nothing to do with the child process at the OS level. It's just the command prompt will be different. Now we are going to create a child process. Let's look at what is there in the first function. First, let's look at the declaration, see whether it has come to the child. Yeah, it does. Shall we now run it? We should be able to run it within the child. Okay, it works. So parent can define a function, export it, the child can inherit it and run it. If we call it, it's going to show the content of the function and run it for us. Pretty good. Okay, this is one method of defining a function and exporting it. For this particular demo, I'm not going to use this particular first method. I'm going to define a second function, which is slightly different. Let's run that first. Second function. It's going to be defined like an environment variable. Okay, so it starts with open and close parentheses, one space, a curly braces, a space, and then your function. Let's say this is the second function, right? And you could say something like this. Okay, let's look at what is there inside the second function. Should be this one. If we just do declare now it's going to be fun, because okay, declare second function. This is not going to show us the, hopefully it will not show the function definition, because we didn't create the function as we did earlier. We were just creating here a simple variable name, right? Second function is a variable name and the values are here, but this is the only value, sorry. So it's a key value pair. Okay. All right. So if this is empty because we have not really defined function in a real sense. Okay. So let's, however, export this variable second function. Now it's exported to the child. Now let's do this. Create another process. Let me change the prompt to the child. Okay. Now let's look at whether we can see the value of the environment variable second function. Okay. This is not okay. I think I made a mistake. Let me fix this mistake. What did I do? What did I do? I have a second function. Echo is showing us declare is empty. And then I went into the bash. It should not be showing me this line. I made a mistake somewhere. Let me try to debug this. Okay. One small mistake I made. This is bash program that is creating me a child process. It's not the buggy bash. Okay. The bash vulnerability that I'm going to talk about is the Shellshock vulnerability. Requires us to use the buggy bash function. So I shouldn't be using regular bash. So let me get out of the child and use the buggy bash version. Yeah. So now let's try. Let's see what happens when you do this. Okay. This is better because it's not treating my second function as a variable. It's treating my second function. If you compare, I am in child, right? And I typed second function, it's empty. But in the parent, I got something here, right? That's because of the way the bash Shellshock bash process is parsing our definition. Okay. Okay, so now we can do this. Declare -f second function. Okay, what you see here now, we are in child. We see the definition as a function as opposed to a variable, because in the parent process, when we did declare, we got nothing. We got empty string. Here we got the function. So our variable has been treated as a function for some reason. That's basically another way to define a function in bash. Now, of course, we can call it in our child. It should be able to run and show the output. So far, we have not really exploited the Shellshock itself. The Shellshock part is coming soon. So we need to be able to inject some code in our, let's get back to the parent. We are in the parent. Let's make a small change to this, right? Let's call it evil function. Okay. The evil function is going to be adding some extra code after the definition. Okay. You see here there is a bracket, curly bracket that I'm closing. I'm going to sneak in some extra code, and you will see that that extra code gets automatically activated. Okay. That's what I'm going to show now. So let me put some simple code here. Okay. Some simple code really. Echo, is it surprising? Okay, this is what I'm going to put as an extra code. Everything here is extra code. Okay, I'm still in the parent process. Okay, now I'm going to export this, of course, to the child. Right now, the child should be getting this variable, but it will be interpreted as it will be interpreted as a function, of course. So let's try the Shellshock. Bash Shellshock is basically the same as the regular bash, but it's the vulnerable bash version. Okay, just to be clear. And surprising, it is coming. It's exactly the same thing that we said. Okay, same thing is coming. This is because there's a bug in the Shellshock parser, rather the bash parser, that when it sees a variable which has the open and close bracket like this, regular parenthesis, and then a space, and then a curly brace and a space, everything else here is treated as the function definition. But did you notice that this is the second function is not even printed here? Nowhere did we see here, right? Nowhere. That's because we are not calling the evil function necessarily. This part, is it surprising, is automatically called by the bash program. The vulnerable bash program automatically treated everything after the first semicolon here. This one, the one that comes after the right curly brace, is considered as code. So anything that you put in here is treated as code and gets automatically executed. Okay, that's basically the high-level idea of a Shellshock vulnerability. All you need to do is create an environment variable, put in some code after the right parenthesis, right curly parenthesis, and then that code will be automatically executed by the program called bash, which is open source, developed back in 1980s. The bug was discovered around 2014, at least that's when we know it in public. So it's about say 25 years or so, not disclosed to the public. Okay, but we don't know, of course, whether anyone else know it already or not, because this seems to be like a serious one, right? Just put in some extra code, it gets executed. You don't need to know anything about computer science or low-level memory details like the ones that we talked about in other videos. This one is extremely simple in that perspective. Okay, so now during the next part of the lecture, I will show you how this can be exploited further by attacking a web server. So I'm going to make use of this basic knowledge we got and show a complete demo of exploiting it through a simple Apache web server. Okay, that's pretty much what I wanted to talk to you today.